Okay, so dimensional analysis is actually somewhat intuitive, and sometimes you probably use it without even knowing it. So, just for an example, imagine you know no equations about velocity. You just kind of know what it is vaguely, and you're trying to figure out how fast somebody drove from your house to their house. And you know the time it took, and you know that the distance between the houses is a length L. So the velocity you know will just depend on the two things you know. It has to. That's the only two things that are really involved here, the distance and the time. So you know that velocity will be proportional to the length to some exponent that you don't know and the time to some exponent that you don't know. That's just, it depends on them, but you don't know exactly how. And you also know, just from your vague feeling about what velocity is, you know that it's in units of meters per second. So to get meters per second, you know that must be a distance over a time. So that means if you have a equals 1 and b equals minus 1, then that gives you meters per second. And given that length is the only distance thing here, the distance between the houses is the only distance involved, and there's only one time involved here, you know that the equation is velocity is just the distance over the time. And that's dimensional analysis. I know it's a simple example, but the more complicated examples are just the same idea, except you're trying to get to something like, say, joules or newtons, and you might have some things like density and times and a few different things, but all you're trying to do is just get to the right units, like we got to meters per second here.